Hi Algebra 2. Today we're going to continue with Lesson 5-6. So today we're going to be learning about the discriminant. So yesterday we talked about the quadratic formula and we practiced solving for x using the quadratic formula. So today we're going to talk about the discriminant. It's actually pretty simple. So right now I'm on textbook page 358. Okay, so textbook page 358, and actually at the bottom of page 357 they give you the definition for the discriminant. Alright, and then if you look at page 358, that's the bottom chart that I'm looking at here that says discriminant. So again, textbook page 358, you should be taking notes. So at the top of your notebook you should be writing 5-6, the quadratic formula, and then discriminant, and we're going to be doing example 3. Okay, so the first thing I want you to see is that the discriminant is actually what you see underneath the square root here for the square root sign. So b squared minus 4 times a times c is our discriminant. Okay, our discriminant actually tells us a lot about a graph. So when I look at the discriminant, okay, again, b squared minus 4ac, if you were to evaluate it looking at standard form, okay, ax squared plus bx plus c, alright, we're taking b, squaring it again, minus 4 times a times c. When you solve the discriminant, okay, if your discriminant when you solve it is greater than 0, you have two distinct real solutions. Two distinct real solutions are two places that this parabola crosses the x-axis. See it? So when it crosses the x-axis, it's called distinct real solutions. And here I have two distinct real solutions. If b squared minus 4ac equals 0, that means I have one distinct real solution. One distinct real solution is when my vertex is at 0 here. If you see that, we only cross the x-axis once. Okay, when it crosses the x-axis once, anywhere along the x-axis, that means our vertex lies on the x-axis, and therefore we only have one distinct real solution. And then when b squared minus 4ac is less than 0, that basically means we have no solutions along x. So if you see here, right, my parabola is above the x-axis, or it could be below the x-axis, which means we have no distinct real solutions. However, because it crosses the y-axis, it's called non-real complex solutions. So this means we have two distinct non-real complex solutions. However, if you said no distinct real solutions, I would count that as correct as well. Okay, so here I just want you guys looking at the x-axis. So here you could say two distinct non-real complex solutions, or you could just say no distinct real solutions if that's better for you. So I'll write that in here if I can find my pen. So no distinct real solutions, okay, would be your other options. So you should copy these down into your notebook. If you want to pause right now, you can pause this video and do so at this time. You want to know what each of these solution sets would look like, depending on your discriminant, okay? Alright, so now we are going to start with example 3. Get this set up. There we go. So example 3, alright, can you see that? So this one here, I just want to add it in if you guys can see it. I'm also adding in or no distinct real solutions, okay? Alright, so example 3. Example 3 in your book says, find the type and number of solutions for each equation. Okay, so for example 3a, I have x squared minus 6x equals negative 7. So the first thing I need to do is put this into standard form. So I need to zero out this function, it's called. Okay, so I'm going to take negative 7 and bring it to the other side. And I'm going to make this x squared minus 6x plus 7. again, I add 7 to both sides to make this 0. Okay, so I want to take this negative 7, jump the wall, or the equation sign, and make it positive, or what we're doing is adding 7 to both sides. Okay, so now I have it set to standard form. Once it's set to standard form, all I have to do here to find the discriminant is to identify, can you see that? This way. There we go. So the only thing I have to do to find the discriminant is to identify A, B, and C here. Okay, so when I look at this, find a different marker. Okay, A equals 1, B equals -6, and C equals 7. Okay, so now that I identified A, B, and C, all right, my discriminant is going to be B squared minus 4AC, right? B squared minus 4AC. So now I'm just substituting -6 squared minus 4 times 1 times 7. And now I'm just going to simplify. So -6 squared gives me 36. And then -4 times 1 times 7 gives me -28. Okay, and then if I subtract 36 minus 28, that's going to give me 8 as my discriminant. So if I have 8 as my discriminant, okay, that's my answer. So my discriminant is 8. And therefore, if I come over here and I ask you, first tell me what the discriminant is. So it's 8, okay? And then I want you to tell me the number of solutions. So my number of solutions, right, B squared minus 4AC, that's my discriminant. If my discriminant is greater than 0, then I have 2 distinct real solutions. My discriminant is the number 8, so 8 is greater than 0, therefore I have 2 distinct real solutions for this quadratic function. Okay, now moving along to example 3b. So here I have x squared minus 6x equals -9. Okay, again, I'm trying to find the discriminant, and then I want to know the number of possible solutions for this quadratic function. So when I rewrite this, the first thing I want to do is put it into standard form. So to do that, this -9 needs to go to the other side. To do that, I'm adding 9 to both sides. Okay, I want this function to equal 0. So when I do that, I'm going to rewrite my function as x squared minus 6x plus 9 equals 0. Alright, so now I've zeroed out my function. I've put it into standard form. So now I can identify A, B, and C. So here A equals 1, B equals -6, and C equals 9. Okay? The number in front of x squared is always A, right? So this is ax squared plus bx plus c. B is always the number before single x. And then your constant is the number without an x value. And so that would be c here. All right, so I have 1, -6, and 9. So now, again, to find the discriminant, I'm just going to use this formula here, b squared minus 4ac. So I'm going to take b and replace it with -6. Minus 4 times a, I'm going to replace with 1. In c, I'm going to replace with 9. And again, I'm just going to simplify this. -6 squared is -6 times -6, which gives me 36. Okay, and then I have -4 times 1 times 9 gives me -36. 36 minus 36 equals 0. So my discriminant here is, that looks like an apple, not 0. There we go. My discriminant here is 0. So when I look over here, b squared minus 4ac equals 0. You should have these in your notes. All right, this equals what? What do we say on my last chart? My chart, it says that if my discriminant equals 0, then I have one distinct real solution. So one distinct real solution. So my answer to this, discriminant equals 0, and I have one distinct real solution. Okay, now I'm on example 3c. And again, we're trying to find the discriminant and the number of solutions. So here I have x squared minus 6x equals -11. First, I need to put this into standard form. And by now, we should know how to do that, okay? I'm just taking -11, bringing it to the other side, and zeroing out my function. So now it's in standard form. So here, for standard form, a equals 1, b equals negative 6, and C equals 11. Okay, everybody see that? So now again, I'm going to use my discriminant formula here to find the discriminant. So b squared minus 4 times a times c. All right, I'm just going to substitute. So instead of b, I'm going to put negative 6. Okay, instead of a, I put 1, and instead of c, I put 11. So I'm just substituting in a, b, and c. Now I'm going to solve. Negative 6 times negative 6 is 36. And then I have negative 4 times 1 is negative 4 times 11 is negative 44, or minus 44. So now I have 36 minus 44. Remember, if I have 36, this is like a positive in front of it, right? If I have positive 36 and I take away 44, I'm going to end up in the negative. Or another way to look at it is to keep the sign of the larger number. So if I have 36 and 44, 44 is bigger than 36. So my answer is going to be negative. And I subtract those two numbers. So 44 minus 36 gives me 8. So my discriminant here is negative 8. When I look at my chart over here, okay, my discriminant is less than 0. So negative 8 is less than 0. Therefore, my solution to this is two distinct non-real complex solutions. Or in other words, we don't cross the x-axis. So my parabola never intersects x. My parabola is above or below the x-axis, and therefore we have two distinct non-real complex solutions. Or you could say no distinct real solutions, if that's easier for you. Either one is correct. Okay, we have a few minutes left, so I want to just go over example 4 next. Okay, so example 4 kind of wraps up this whole section. Okay, so if you look at example 4, it's a word problem. I expect you guys though to be able to do this, okay? So, let me just zoom this in. Alright, so example 4 says, the pilot of a helicopter plans to release a bucket of water on a forest fire. The height, y, in feet of the water, t seconds after its release is modeled by y equals negative 16t squared minus 2t plus 500. Okay, so this is right on page 359. Okay, so again, y here is the height in feet of the water, and then t is the number of seconds, okay? So then it says the horizontal distance x in feet between the water and its point of release is modeled by x equals 91 times t. At what horizontal distance from the fire should the pilot start releasing the water in order to hit the target? So in order to find x, right, x is our horizontal distance. If you look in your book, it shows you a picture of that. So we're trying to find the horizontal distance. I can't solve for x unless I first know what my value for t. So that's what we're going to solve right now. Okay, so I'm going to use this function here to solve for t. So to do that, instead of x, I have t. It's the same thing here. All right, guys, so I'm going to use my quadratic formula to solve this. All right, so I'm going to, again, just substitute for a, b, and c in my quadratic formula. And I'm trying to solve here for t. So y, we're going to zero out y. Okay, so basically when y equals 0, what does x or t equal is what we're asking. So I'm going to now solve. All right, so here, t or x is going to equal what? So I'm going to substitute. Here I have a, b, and c. So negative b plus or minus the square root of b squared minus 4ac all over 2a. That's my quadratic formula. So instead of b here, I'm going to put what? Negative 2. Okay? And then instead of b here, I'm going to put negative 2. Instead of a and c, negative 4 times a times c, I'm going to put negative 16. I'm like really cramped here. That's a negative 16. And then c is 500. Okay? And then a down here is negative 16. So when I simplify this, alright, I'm not going to get into it. You can look it up. I'm actually running out of time. I'm going to have to create a new video. No!